do some numericals related to laws of motion. Okay. So we have three laws: first law, second law, and third law. First law is laws of inertia. Like unless you apply external force, it will not change the state of rest or state of uniform motion. Okay. Second law is rate of change of momentum is equal to force. And third law is each action has equal and opposite reactions. So examples are like rockets or the jet engine and all. So when the exhaust gas goes backward, it will try to propel it forward. Okay. So those are the laws. So there are some. So this rate of change of momentum is equal to force. Okay. And there is another important thing is like say when a lift is accelerating upward. Okay. So this is you are standing on this lift. Your mass is say m. Okay. When your mass is m, actually you will feel like when you are going up, there will be a apparent increase in your weight. Okay. Why it is so? Because that R is nothing but your apparent weight. Okay. So this system, if you see, you can write it as R minus mg is equal to m, right? Because this is moving at a acceleration a, so R minus mg is equal to ma. So R is equal to m into g plus a, right? So suppose you are moving at a acceleration g, okay, upward movement at a acceleration g. That means R will become is equal to m into g plus g, right? So it will become like 2mg. Okay. So this is called like you will feel heavy when you are moving at a acceleration, upward acceleration a. Okay. Similarly, suppose this lift is falling down. Okay. Say this lift you have, and this lift is like mg anyway will act like this, and r will be like this, and your acceleration is down. Okay. If acceleration is down, then r will be m into g minus a. Right? When it is g minus a, this will be like when your a becomes equal to g, when your a becomes equal to g, r will become m into g minus g. Okay, that means 0. That means this is called free fall. Okay, so I just hold you and I leave you. So the acceleration due to gravity is acting on it. So during free fall, you will feel completely weightless. Okay. So same is the case of that spacecrafts. Okay. There it is in the state of free fall. Okay. That's why they will feel weightless there. Okay. So so these are the meaning of g value. So if you are accelerating at a high g, okay. So if you are accelerating at say 2g, 3g and all, so your apparent weight will increase. Okay. So like this aircraft and all, this fighter aircraft are subjected to 9g load. That means if it is moving upward at 8g acceleration, in addition to its own weight mg, it will get another 8g load. Okay, when it is accelerating upward, and when the aircraft is falling downward free fall, that is kind of weightless. Okay, and there can be some negative acceleration also, like say minus 3g. That means it will be so that in this formula you can put it, you can find out. So I have seen there are good number of questions related to this. Okay, so this R is equal to m into g plus a when you are moving upward, and R is equal to m into g minus a when you are going down. Okay, so that is one, and another very common numerical is this. Very common numerical, you should remember the formula is like the connected body over pulley. Okay, let us say this is my pulley. Okay, so this is my pulley, and let us say it is being, this is the supporting point of here. Okay, so so I have, so I have a structure like this, then and okay, So I have something like this. So the a system like this. So let us say this mass is m1 and this mass is m2. Okay. So this is the system. Okay, so for this system, without suppose it is moving downward at an acceleration a. Okay, so this will have common tension here, and here you will have common tension. Okay, so if there is a friction in the pulley, the tension will be different. Okay, because this side and this side, the tension will be different. Okay, the tension in the wire will be different if it is a friction pulley with friction. But if it is a frictionless pulley, normally you will get question related to frictionless pulley. Okay, because friction pulley it will take more time. What you need to do is you need to understand. Okay, so this kind of system, this is a very common one. The acceleration is equal to m1 m2 minus m1. So m2 minus m1 divided by m1 plus m2 into g. Okay, so this you just remember that in this kind of system, on the top the difference of mass, in the bottom the addition of mass into g value. So the system will accelerate at that much of acceleration. Okay, and there can be a question. Okay, so there can be a question on what is the tension. Okay, so this tension will be 2 m1 m2 divided by m1 plus m2 into g. Okay, so this formula also you remember for this kind of system, m1 2 into m1 m2 divided by m1 plus m2 into g. Okay. Okay. So these are some of the important things, and there is something called this coefficient of friction is equal to tan theta, right? Yeah. So that also you have to remember, and then okay. So there are some important formula. The centripetal force, you know, centripetal force is equal to mr omega square, right? Yeah. And then some other like the shape velocity of the cyclist while turning. What is the shape velocity? So that it does not skid. Okay. So Vmax is equal to Rg into tan theta. Okay. Square root. Square root. So that the cyclist is not going to skid. Okay. So similarly, the maximum velocity with a car, when car takes a circular path. Okay. So that maximum velocity, if the coefficient of friction is mu, will be mu s into r into g. Okay. So this one is the banking angle comes into picture. Yeah. So it has to incline a bit. So that's why rg tan theta. But this is for a cyclist. Okay. This is for a cyclist. Okay, and this is for a car. So you are moving. So your car is moving with some velocity, and if the coefficient of friction is mu s, then and if the radius of this car is r. Okay, if the radius is r, mu s into rg square root. Okay, so these you have to remember. Okay, so these are some of the main formulas. So we will try to do one numerical on third law of Newton. Okay. So what they are saying, a man fires a bullet of mass 200 gram. So small m is equal to 200 gram. This is the small m which is equal to 200 gram, and at a speed of 5 meter per second. So the v small v you can say. Okay. Let us say this is small v is equal to 5 meter per second. Okay. So this is a man fires a bullet 200 gram at a speed of 5 meters per second. The gun is of mass 1 kg. So capital M is 1 kg. Right? So 1 kg is by what velocity the gun is that rebounds backward. Okay. So this is like say before firing the gun, so let us say this is my gun. Okay, so let us say this is my gun, and this is mass is m and capital M, and this bullet is small m, right? Small m. So before, so this is like this: m1 into capital V1 plus small m1 into capital V1 is equal to m2 V2 plus m2 V2, right? So at rest both things are 0. Okay. Then when you are firing the bullet, it will become like I want to find out capital V, right? So let me write it as V1, right? Okay. Okay. So this is V or whatever. So let me write it as like M2 V2 plus M1 V capital M2 V2 plus some small M2 V2, right? Is equal to 0, right? So now I want to find out the recoiling velocity. That is the speed of the gun. Okay. So that will become small m2 by capital M2. So anyway into the small v2, right? So this m2 by this is m2 by m2 is nothing but m by m, because mass does not change. m2 by v2 into your v2. So the capital V2 is equal to small m by capital M into your the speed of the bullet, which is 5. Okay. So now you can see that this is 200 and this is 1000 into 5. So this will become 1 by 5 into 5. That means 1. Okay. So this is a numerical on Newton's third law of motion. Okay. You have started? So there is another numerical, a bomb of 12 kg mass. So a bomb of 12 kg mass, okay, a bomb of 12 kg mass explodes into two pieces of 4 kg and 8 kg. So this is exploding into 4 pieces. One is 4 kg and one is 8 kg. Okay. So it is exploding into two pieces, 4 kg and 8 kg. If the momentum of 4 kg mass is 20 Newton second, so the 4 kg mass will have one momentum and the 8 kg mass will have another momentum.
You can find V and then continue.
So here you can find it. There is a question is momentum and kinetic energy relation.
PMV and then find V and put it in conservation.
So before explosion it will be momentum is equal to 0. After explosion it will become M2 V2 plus capital M2 V2. So this 0 is equal to again small M2 V2 plus capital M2 V2.
Same.
Okay.
You have to find velocity.
So then there. So this is one question. Okay. Okay. So then there is one question like a force 2ig plus 3jn. So 2i plus 3j. This is a force. Okay. This 2i plus 3j acts on a body of mass 1 kg, which is rest initially. Okay. So this force is acting on a body. So this is a body which is of 1 kg. Okay. So then the acceleration. Okay. So this is my force. Okay. And this is my mass. Okay. So mass is 1 kg. So the acceleration will be just by force by mass, right? So this will become 2 by 1 I plus 3 by 1 J Newton. So this is your acceleration.
Meter per second square.
Meter per second. Okay. So these are some typical examples. Okay, a ship of mass 2 into 10 kg, 2 into 10. Okay, so a ship of mass 2 into 10 initially rest pulled by a force through a distance of 2 meters. So this is something like this. Okay, so another numerical that a ship of mass of the ship is to the power 7 kg. Okay, so if you have a ship of mass of the ship is equal to 2 to the power 7 kg. Okay, the mass of the ship is 2 to the power 7 kg, and it is you are applying a force of 5 into 10 to the power 5 Newton. So force is 5 into 10 to the power 5 Newton. Okay, we are applying a force of 5 into 10 to the power 5 Newton through a distance of 2 meter. Okay, so a distance S is given as 2 meter. Okay, so force is given, mass is given, and distance is given. So with all these things, you have to find out the speed of the ship. Okay.
Is acceleration you can find.
Okay. Assuming that the resistance due to water is negligible, what is the speed of the ship? So first you can get your acceleration. So acceleration is equal to F by L. Okay. So after you know the acceleration,
You can put
and
it
then
in
you can use this formula
v square minus u
v
square.
square is equal to 2s. Okay. So
You will be
these are some of the numericals and Newton's law that you can do. Okay, and there can be good number of numericals related to that apparent weight. So lot of numericals are there related to that apparent weight. Okay, so one beautiful numerical is a man weighing 60 kg is in a lift. So your weight is say 60 kg. Okay. So you are of weight 60 kg, and a man weighing 60 kg in a lift moving down with acceleration 1.8 meter per second square. So this lift is moving down at acceleration 1.8 meter per second square. Okay. So the force exerted by the floor on him. Okay. So when it is going down, you will when it is rest, what is the force exerted by floor on him? So this is the mass mg. Okay, and this will be a reaction. So the reaction is nothing but the force exerted by floor on him. So R will be equal to mg. Okay, so that will become 16 to 10. Okay, so 600 Newton. Okay, but when it is moving at acceleration 1.8, so this will become R is equal to m into say 10 minus 1.8. Okay. So this will be 60 into, let us say this is say 8 or whatever, roughly. Okay, so this will become something equal to 480 Newton. Okay. So this will be there can be n number of questions, like if it is going upward, it will become R equal to m into
G plus
G plus A. Okay. And if any question comes that it is falling at a velocity, acceleration g, that means that is called free fall. So in free fall, reaction will be equal to 0. That means you will feel weightless. Okay. So these are some of the questions related to Newton law. Just I will solve one or two questions related to half life. Just 2 minutes. 2 minutes I will do one half life question. Okay, that will come. Okay. Okay, so one question on half-life. A radioactive element has half-life 15 years. Okay, so half-life 15 years means n by n0 is equal to half. Okay, okay. So if your half-life is 15 years, so in 15 years n by n0 will become half. Okay, so they are asking in 30 years how much will remain. Okay, so n by n0 will in 30 years will become half to the power 30 by 15. Okay. So this will become half to the power 2 is equal to 1 by 4. So in 30 years it will become 1/4. Okay. And suppose somebody asks you in 60 years. Okay. So n by n0 will become half to the power 60 by 15. That means half to the power 4. Okay. Which is equal to 1 to 16. So this is one concept of half life. Okay. And that the helium. So 2, 4. So your alpha ray is equal to if a alpha ray is getting emitted, then it is nothing but a helium, right? So they are guessing that suppose a radioactive element, initially it was 22688. So 226 radium, sorry, this is 2 radium 226 and this is 88. This has become say PB82. PB82. Okay. PB82 and the mass is 206. Okay. So the question is how many alpha rays are emitted. Alpha ray is nothing but a helium. So you can see that 226 minus 206 divided by 4 because 4, right? So this is 20 divided by 4. That means 5 alpha rays are emitted. So these are simple questions you should never leave. Okay. So this is about half life and your
decay.
Decay. And so the common formula for half life, if you have to derive from fast principle, n is equal to n0 e to the power minus lambda into t. So otherwise n by n0 is equal to e to the power minus lambda t. Okay. And then there is something called average life. So average life formula is 1 by lambda. Okay. But t half life is equal to 0.693 by lambda. Okay. Otherwise you can write it as t average life into 0.693. Okay. So that is the relationship between average life and the half life. Okay. So alpha ray, you know, then beta ray is emission of one electron. This is alpha ray. Beta ray is emitting an electron and a proton. Okay, so beta ray is removal of one electron and a positron. Okay. So these are some of the quick questions. We does not take much time, but if you know just the concept, you can solve. So any problem related to half life, you can solve like this. And suppose 15 years, 30 years, just twice to the power like this formula. Just n by n0 is equal to half to the power the number of years divided by half life. Like 15 years is half life. So after 60 years, how much will remain? So this formula will govern it. Okay. So just we have solved some numerical related to Newton law and half life. Okay. Okay. Thanks.